Imagine typing one sentence and receiving a usable soundbed as a WAV file. Today we are building exactly that, a Python app that turns a text prompt into AI-generated audio. An AI coding agent will speed up the busy work, while we keep control of the architecture and debugging. By the end, you will have a clean interface and a repeatable generation workflow. Here is the whole build in one frame. A text prompt and a few controls enter our Gradio interface. Python passes them to a text-to-audio model, receives a waveform and sample rate, then writes a downloadable wave. The agent is not the application. It is our pair programmer. It proposes files, spots, edge cases, and explains the code we choose to keep. That separation is the difference between a flashy demo and a project you can maintain. First, we create an isolated project and let the agent propose a minimal dependency list. Notice the word minimal. Installing every AI library is slow, fragile, and impossible to explain later. For this version, we only need PyTorch, transformers for the model pipeline, Gradio for the interface, NumPy for arrays, and SoundFile to write audio. We pin versions after the first successful run, so a future install produces the same environment. Now we load the generator once, not every time someone clicks the button. The agent turns that idea into a small loader function. It chooses a GPU when one is available and safely falls back to CPU. The first launch may download model weights, so we make that visible in the interface instead of leaving users staring at a frozen screen. Keeping model setup separate also makes it much easier to swap in a faster or licensed model later. Next comes the important boundary. Raw model output becomes a real audio file. We validate the prompt, cap duration, pass a seed for repeatable experiments, then squeeze the generated tensor into a one-dimensional NumPy waveform. We preserve the sample rate returned by the model, guessing it is a classic way to make audio play too fast or too slow. Finally, we normalize carefully and save a fresh wave path that the front end can hand back to the creator. With the engine working, the agent can build the shell around it. Gradio gives us a fast, polished web interface without inventing a front end from scratch. We expose only the controls creators need: a descriptive prompt, clip duration, guidance, and a seed. Examples are not decoration. They teach users how specific prompts produce better outputs, and they give us instant regression tests whenever we change the model. Time for the part every tutorial conveniently skips: the error. Our audio component expects a flat waveform, but a model can return an extra batch dimension. Instead of copying an agent fix blindly, we ask it to explain the shape mismatch. The answer points to a safe squeeze operation. Then we confirm the final array is one-dimensional before writing it. That tiny validation makes failures clear, prevents corrupt files, and turns agent assistance into real understanding. Now we add the difference between a script and a tool. A progress state reassures people while generation runs. Downloadable output, a visible seed, and recent prompt history make experiments easy to repeat. The agent proposes the interaction pattern, but we choose the product decisions. What should be visible, what can wait, and what should never be hidden behind a magic button. Good AI software makes its uncertainty and its controls legible. Let's run the full loop. The terminal launches the app, the browser opens a local URL, and we try a prompt with a clear mood, instruments, texture, and duration. Watch the status change from queued to generating to ready. The output player receives the file path and lets us listen immediately. Test several prompt styles before celebrating. A single good clip proves almost nothing. Consistent behavior across inputs is the real signal. Before deployment, we add the unglamorous guardrails. Keep configuration and any tokens outside the codebase. Limit prompt length and clip duration so one request cannot consume all your compute. Log only what you truly need. Label generated audio clearly and add a content policy that fits the model and your audience. If you use a hosted API, rate limiting and cost tracking belong in version 1, not after the first surprise bill. From here, deployment is a packaging problem. The agent helps us draft a Docker file, a simple health check, and a README with local and GPU instructions. Choose hosting based on the model. A small demo can live on a managed GPU space, while higher traffic needs a queue, storage, and observability. Ship the smallest version that gives creators value. Then measure generation time, failures, and the prompts people actually use. That is the complete loop. Prompt, model, waveform, wave, interface, and feedback. The agent accelerated the repetitive steps, but the win came from treating every suggestion as a draft we could inspect and test. Save this blueprint, build one small vertical slice, and make the next prompt you type produce something you can hear. If this helped, subscribe for the next agent-powered Python build.